Hello all. Today we will look at a very known and commonly used method which is known as TOPSIS. This method is based on the concept that the best alternative should have the shortest distance, that is the Euclidean distance from the ideal solution. Well, the full form of TOPSIS is Technique for Ordered Preference by Similarity to Ideal Solution. Now, we were dealing with the situation of selecting the best mobile phone out of all available 5 alternatives based on 4 criteria, that is price, storage space, camera and looks. I converted the linguistic terms used in looks using this 5-point scale. Excellent was given 5 point and the low was given 1 point. Now the values were substituted. In TOPSIS, vector normalization is done. This is the formula for the vector normalization. First, I will show how this denominator is calculated. I have shown how the denominator is calculated for price. The square root of the squared summation gives the denominator. All these values 250, 200, 300, 275, 225 are squared and added, and the root of the value is taken. Similarly, we can calculate values for other criteria also. The performance value in each cell is divided by the rooted summation of square value. Now these are the performance value of each cell. So here we can see that 250 is divided by 564.579. That is, the performance value of each cell is divided by the rooted summation of square value, which gives us the normalized matrix. So here we can see that 250 is divided by this value. Similarly, in the next cell, 16 is divided by 53.0659. 12 is divided by 29, 5 is divided by 8.3666. Similarly, we do it for all other cells. This is the normalized decision matrix. Now, the value in each cell is known as the normalized performance value. Next, we multiply the weights of each criteria with the normalized performance value of each cell. So here we can see that 0.25 is being multiplied by the normalized performance value. Similarly, this is the weightage for storage space, weightage for camera, weightage for looks. Each weightage are being multiplied by the normalized performance value. Now this is a weighted normalized decision matrix. Next, we calculate the ideal best and the ideal worst value. For non-beneficial criteria like price, lower value is desired. Thus, in column 1, minimum value, that is 0.0886, is the ideal best, and the maximum value, that is 0.1328, is the ideal worst. But in case of beneficial criteria like storage space, camera and looks, maximum value is desired. So ideal best will be the maximum value and the ideal worst will be the minimum value. This is the formula for calculating the Euclidean distance from the ideal best and ideal worst. This is a formula for calculating the Euclidean distance from ideal best. So here I will show you how to calculate the Euclidean distance. First, I am calculating the Euclidean distance for the first alternative, that is mobile 1. We take the difference and then square it. Finally, we sum all the squared value and then take the root or the square root. So here we can see that the difference is being squared and added, and finally the root has been taken. which gives a value 0.0863. This is the value for the first mobile or the first alternative. Similarly, I have calculated for the second alternative, that is mobile 2. It comes out to be 0.1198. Similarly, we can calculate all the Euclidean distance from the ideal best. These are the values. Next, we calculate the Euclidean distance from the ideal worst. Similarly, we calculate it for the ideal worst. The difference is being squared and summed up, and then the square root is being taken to get a value, that is 0.0990 for the first alternative, that is mobile 1. Similarly, we can calculate the Euclidean distance from the ideal worst solution. These are the Euclidean distance from the ideal best and the ideal worst. Now the performance score is calculated. This is the formula for performance score. It is denoted by PI. Now we add these two values, and then this Euclidean distance from the negative solution is divided with the sum. So based on the performance score, we can rank the alternative. So here we can see that mobile 3 is the best alternative as it is having the maximum value. Throughout this video, we calculated the Euclidean distance. I just want to make you visualize how Euclidean distance actually looks like. So suppose there are 2 points, x1, y1 and x2, y2. Now the distance, the x coordinate distance between the 2 points is x2 minus x1. Similarly, the y coordinate distance between the 2 points is y2 minus y1. So this will be the Euclidean distance. Now this is the Euclidean distance for 2 points in 3 axes, that is x, y and z. So here we can see that A is the distance between the 2 points, or the x distance between the 2 points, that is x2 minus x1. Similarly, B is the y-axis distance between the 2 points, that is y2 minus y1. And D, this is D, which is the z-axis distance between the 2 points, that is z2 minus z1. So here we can see that C square is equivalent to A square plus B square, and we wanted to calculate the Euclidean distance L between the 2 points. These are the 2 points. This is the first point and this is the second point. We wanted to calculate the Euclidean distance between the 2 points, and which is equivalent to under root C square plus D square, and C square is nothing but A square plus B square. So Euclidean distance is under root D square plus A square plus B square. And here we can see that the values of A, B and D are x2 minus x1, y2 minus y1, z2 minus z1 respectively. That's all for today. Thank you and have a nice day.